Now let's talk about various operators in Java. So we have these four categories of operator, broadly speaking. So let's discuss each of them one by one. The very first we have is arithmetic operators. So just like in real life we have addition, minus, similarly we have arithmetic operators in Java to perform certain calculations. We have addition, subtraction, multiplication, division, and apart from these four, we also have a modulo. So this obviously gives me the sum, this gives me the difference, this gives me the multiplication, this gives me the division, this gives me the quotient, and this gives me the remainder. So if I divide 5 by 3, I get my result as 1, the division gives me the result as 1, and this modulo gives me the remainder. So 5 modulo 3 gives me 2. Similarly, if I do 4 modulo 4, I get remainder as 0. So 4 modulo 4 gives me 0. So these are the arithmetic operators that we have. Then we have increment and decrement operators. These arithmetic operators, going back to arithmetic operators, are binary operators, means they operate on two numbers. Whereas this increment decrement is a unary operator that operates on a single number. So what is this increment decrement? It looks generally like this. So this is double addition and this is double subtraction. So let's say I have a variable b. If I do b plus plus, this is increment. If I do b minus minus, this is decrement. This plus plus increments the value by 1 and this minus minus decrements the value by 1. So if let's say my b is 5, then this b plus plus will change the value of b to 6. And this b minus minus will change the value of b to 4. So let's take another example. Let's say have int a equal to 3. So if I do a plus plus and I print this a, my result will be 4. And if I do a minus minus, my result will be 2. Now again in this increment decrement we have a variation. We have a postfix operator and we have prefix operator. So postfix is what we have seen till now. This b plus plus is postfix, whereas this plus plus b is prefix. Let me write it here. This plus plus b is prefix. What's the difference between the two? So if I simply do this a plus plus or plus plus a. So let's say this is a standalone statement. There's nothing else here. We have just int a equal to 3, a plus plus. Then let's say I have in the next line print a. Okay, so let me write it again. Let's say I have two programs, int a equal to 3, a plus plus, print a. Then again let's say I have int a equal to 3 plus plus a, print a. So again I will repeat since it was not visible. So we have this int a equal to 3, a plus plus, print a, int equal to 3 plus plus a, print a. So these are let's say two different programs. In both the cases, this print statement will give me 4. Okay, this print statement will give me 4. So where is this postfix and prefix making the difference? So let's say I have something like this. I'll take a new sheet. So let's say I have something like this. A plus 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 b plus plus. Let's say we have some variable c equal to a plus plus b plus plus. So let's say a is equal to 3 and b is equal to 4. So what do you expect the result to be? Do you expect the result to be? You will say that a plus plus gives me 4, b plus plus gives me 5. So my result should be 9. But actually the result for c is 7. So if after this particular statement, if you print a, b and c, you get the value of a as 4, b as 5, but c as 7. Why? Because this is postfix. So what happens in postfix is that So first, whatever expression has to be evaluated will be evaluated, and then the increment or decrement will happen. So in this case, what happens? First, addition is done, and then increment or decrement happens. In case I would have written this as plus plus a plus 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 b, in that case, before this addition happens, this plus plus a and plus plus b would have worked, and I would have got my result of C as 9, A as 4 and B as 5. So in postfix, first whatever operation has to be done gets done, and then the increment or decrement happens on that particular variable. And in case of prefix, first increment or decrement happens, and then whatever operation has to be done takes place. So this is increment and decrement operator. Next we have relational and boolean. So generally relational will have the operators like greater than equal to, less than equal to, and not equal to. So this is something that is just like the real life. We are comparing two numbers, whether this particular number is greater than this or greater than equal to this, less than equal to this, less than equal to this, or equal to this and non-equal to this. So let's see few examples. Okay. So here we have taken two variables a and b. We have initialized them as 4 and 6. And here we have applied all the relational operators. The result of these relational operators is a boolean. Boolean we have seen gives me only two values, true or false. So depending upon whether this particular relational operator is giving me the true value or the false value. So here we are checking a greater than b. So do we have a greater than b? No. So the result of this will be false. Again, here we are checking whether a greater than equal to b? No. So again, this will give me false. Here we are checking if b is greater than a. B is greater than a, yes. So this gives me true. This again gives me true. Okay. So here we have double equal to. In case of Java, C++, we don't use single equal to for the equality. Reason being, single equal to is used for assignment. So we use double equal to for checking equality. So here, do we have a equal to b? No. So the answer will be false. This is for checking whether a is not equal to b. So we have a not equal to b, right? A is not equal to b. So we have this as true. Okay. So talking about the assignment operator, assignment is also an operator that we have seen is used to initialize the value. So let's say I have something like this. A is equal to a plus b. There is a way to decrease the size of this particular expression. We can also write this as a plus equal to b. So this is the shorthand operator. What I have done, I have reduced the size of this particular assignment. Now let's go on to see another set of operators, which is bitwise operators. So next we will discuss bitwise operators. So bitwise operator is something that work on the bits, that work on the bit level. So various bitwise operators are bitwise AND, bitwise OR, shift operator, and complements operator, and XOR operator. We'll talk about them one by one, but before talking about bitwise operators, we would like to discuss about logical operators. So we have another set of operators called logical operators. So before we go on to discuss about bitwise operators, we will discuss about logical operators. We will see what logical operators are. After that, we will go on to discuss bitwise operators. So we have two logical operator, AND and OR. So let's say I write something like this. I write A greater than B and C greater than D, and I write A greater than B and C greater than D. Sorry, this will be A greater than B or C greater than D. So what are the various things that could happen here? Let's first see this condition. This A greater than B could be true and C greater than D could also be true. Similarly, this could be true and this could be false. Similarly, this could be false and this could be true, or both of them can be false. We will have similar set of scenarios in case of OR. It's just that this particular thing will change. So we can have true or true. We can have true or false, or we can have true or we could have false or true, or we can have false or false. So what happens in case of AND is the result of this particular expression will be true only if both the expressions are true. So in this particular case, if I print this particular expression, so I will get, in this particular case, I will get true. In all the rest of the cases, I will get false. What happens in case of OR is, if either of them are giving me false, if either of them are giving me true, my value will be true. So here I get true, here also I get true, here also I get true, and here I get false. So only if all the expressions, all the comparisons are false, then only I get false. So this is the difference between AND and OR. So this was about logical operators. Let's go on back to bitwise operators. So talking about bitwise operators, we have seen that we have several bitwise operators: bitwise AND, OR, bitwise complement, or bitwise negation, left shift, and right shift. We'll talk about them one by one. So in case of bitwise operator, as I've said before also, the operation happens on the bit level. So let's say I have A equal to 5 and B equal to 10. This will be the bit representation. Let's say they are occupying 8 bits. So this will be the bit representation. This AND will work same as the logical AND that we saw. It's just that this will work on bit by bit. So if I do something like A and B, this is what's going to happen. So this is my A, this is my B. So we will have the AND bit by bit. So first we will have AND between these two. My result will be 0. Here also I will be having 0, 0, 0, and then I will have all 0. So if I do A and B, my resultant is going to be 0. So the result of A and B is going to be 0. So let's do A or B. So in this case, 0, 1 gives me 1, 1, 0 gives me 1, 0, 1 gives me 1, this gives me 1, and these all gives me 0. So A or gives me the result as 2 to the power 0 plus 2 to the power 1 plus 2 square plus 2 cube, which is 1 plus 2 plus 4 plus 8. So I get the result as 15. Now, next we have, okay, I missed to write here. We have one more thing. This is known as exclusive or I can say this is XOR, exclusive OR. What happens in case of XOR is that the resultant bit is 1 only if either of them is 1. So what happened in case of OR is that if either of them or both of them is 1, the resultant is 1. But in case of XOR, resultant is 1 only if either of them is 1. So if both of them are 1, we get the resultant bit as 0. So in this case, let's say I replace this 0 by 1. So what happens? What do I get as the result? This gives me 1. This also gives me 1. This gives me 1. But this gives me 0. So this is going to be my result. So this was XOR or exclusive OR. So we have seen bitwise AND, bitwise OR, and bitwise XOR. Next we have negation or bitwise complement. What this bitwise complement does is that it toggles the bits. It toggles every bit. So if let's say this A equal to 5 is there and this is a unary operator, it operates on a single operator. It operates on a single operand. So if I write something like this, negation of A, what will it do is that it will toggle all the bits of A. So we know that our A is 5. So let's say this is the binary representation of A. What negation A will do? It will toggle the bits. So this 0 will be converted to 1, 1 will be converted to 0, 0 will be converted to 1, 1 to 0, and similarly all of these will be converted to 1. So this is going to be my result. This is negation A. Next we have left shift and right shift. So what happens in case of left shift is that the bits are shifted to the left. So generally the syntax for using left shift goes something like this. So let's say I have A and I have to do the left shift operation. So I will do A left shift and I will give by what number of bits I want to do the shifting. So let's say I put 2, which means I want to shift the bits of A on the left side by 2. So what happens is that the bits are shifted. So let's say 1, 2, 3, 5, 6, 7, 8. This is my window. I put these things here, these bits here. So what happens is that if this is my window, then if I have A shift 2, then first 2 digits, or let's say first 2 bits will be thrown out of the window and rest of the things will be shifted to the left by 2 position. So now it will look something like that: 0, 0, 1, 0, 1, 0. Now this 2 zeros went out, everything was shifted to the left, and now these 2 bits are vacant. So what will I do? I'll fill 0 here. So this is how right left shifting is done. The bits are shifted to the left and the vacant position is filled with 0. Similar case happens in right shift. It's just that whatever is done in left here is done in right in case of right shift. So this was about the bitwise operators. So with bitwise operator, we conclude with operators.